All right, today we're going to talk about classical probability. This is going to be square into chapter 5. And we'll probably break these videos into 2 or 3 different pieces. So just kind of follow along with me and let's see where we go. So basically what we're going to try to do is calculate the probability of anything, or the probability of x, which is going to be the total number of outcomes of interest divided by the total number of possible outcomes. Let me put this in a different way. Your book, for example, is going to have this as the probability of any classical probability calculated is the number of outcomes in set A, and set A represents the outcomes of interest. So it's the same thing over the total number of outcomes. And we're just going to do one over the other. So if I were to say, what are the odds of drawing, say, a heart out of a deck of cards? Well, you know that there are 13 hearts in a deck of cards, and there are 52 total, right? So these are the ones that I am interested, right? All of the hearts are on the top, and all of the cards, we don't really need 2 lines, but all of the cards, and then all cards are on the bottom, right? And that's going to reduce down to 1/4. So basically, you've been doing classical probability all your life, and you probably did it a little formally in high school. And so you should be in a great place when we calculate this stuff. Again, classical probability is when we look. Let's look at a simple die, right? Something like this. You get 1 here, and you get 2 circles here, and then 1, 2, 3, or something like that. And we roll a die. Well, what is the probability? And note the notation that I'm going to start using here. What is the probability that if I roll a die, right? Here's my possible event, that it's going to equal to the number 6. This doesn't mean I'm rolling 6 die, and it doesn't mean that the value is 6, and the value is 6. But this is going to be equal to how many sixes divided by how many sides, right? And so how many 6s are there on a deck on a die? There is 1 6. Okay, note that I'm not using the number 6, but the total number of 6s that exist on the die divided by the total number of possibilities. So this is my possibility of interest. This is the one I'm interested in. And this is the total possibilities. Okay, that is it. That is classical probability at its simplest form. The only other thing when we talk about possibilities and we don't do classic probabilities, we sometimes do empirical probabilities. And that means that we're going to take our die again. And take our die, 1, 2, 3, to make it easier. And I'm going to roll this die like 100 times. So I'm going to roll the die and I'm going to get a 1 and a 3 and a 4 and a 7. Oop, can't get a 7. Let's erase that real quick. Come on, erase. I'm going to make this work if it kills me. Erase. There we go. Okay, 1, 3, 4, 6, 1, 3, 6, 7, and so on. And then I count all the number 1s in the 2, 3, 4, 5, 6. So this is the actual roll of the dice, and this is the number of rolls. And so here, if I add these up out of 100, I should get something like 13 and 16 and 18 and 17 and 15. And I don't know how many's left, but let's say that it is, 18. Adding all of these up is 100. All right, this is an estimation, so don't quote me on here. You know what? We won't do an estimate. We'll do it for real. Let's see what this adds up to. Let me scroll this down just a hair. Let's go ahead and add this up. Where's my calculator? 13 plus 16 plus 18 plus 17 plus 15 plus 18 equals 97. All right, well, let's change this 13. Let's change this 13 to a 16. And that gives us a 100, right? So now I have 100 rolls. Well, now instead of saying, well, look, the probability that my roll will equal to a 6, very classically, right? Classic probability is 1 over 6. Everybody knows that. And 1 divided by 6 is equal to, what, 17 or 16? 16.66 or something. But if I roll the test, right, and I roll all of these over and over again, I just roll and roll and roll and roll and roll, then this is the actual number. Let me change colors here. This is the actual number that occurred. So now I'm saying, hey, look, I don't know what the classic probability is, but I know that I rolled this die 100 times and I got 18 out of 100 rolls. And so now I have the exact same thing and I end up with 0.18. These two numbers are pretty similar. And what's going to end up happening is as I increase the total number of rolls, right? So my rolls, instead of being 100, it turns into 1,000 or 10,000 or 100,000 or however many I have here. What is this? 100 million rolls. We're going to begin to approximate that classical probability. And that's the difference between the two.